Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Azhar Zabir Zubairi, matrix number 200583. I'm from section 402 for Physics 2. So I'm here to explain about question number 13 for chapter 34. So here are the question. A laser beam is incident at an angle of 30 degree from the vertical onto a solution of corn syrup in water. The beam is refracted to 19.24 degree from the vertical. A. Find what is the index of refraction of corn syrup solution. Assume that the light is red with vacuum wavelength 632.8 nanometer. Find its B wavelength, C frequency, and D speed in the solution. So firstly, we have to analyze all the important information that have been given. So firstly, we have the index of refraction of for A. It is 1.0. And then we have the incident angle. Incident angle is 30 degree from the vertical. So however, we don't have the index of refraction for corn syrup, but we have the refracted angle. It is 19.24 degree. And we also have the vacuum wavelength. It is 632.8 nanometer. Alright, so firstly, this question is asked us to find the index of the refraction. So we can use the formula n sin theta equal to n sin theta, and 1 sin theta equal to n2 sin theta. So firstly, we have the n1. So we put the value 1.0 sin 30 degree because it is the incident angle equal to n2 sine 19.24. So here we want to find the n2 index of the refraction for corn syrup. So from that, we have to move sin 19.24 to the other side, and then we calculate. We will get 1.51733. Alright, so we complete this question, and then for B it asks us to find its wavelength. Alright, so we have the formula. Lambda 1 over lambda 2 equal to C over n1 over C over n2. So C, it is the speed of light, right? So we just put all the information that we have. Okay, firstly we have the wavelength in the vacuum, right? So it is 632.8 nanometer over wavelength 2. So we have to find the wavelength in the corn syrup, right? So we just put the information. The speed of light 3 times 10 to the power 8 over 1.0, the index of refraction of the air, and then same 3 times 10 to the power 8 over 1.1733. So how I get this is from here, right? Because we already have been asked to find the index of refraction for the in the corn syrup. Alright, so then you just divide both of this. They will get 3 to the power 10 3 times 10 to the power 8 and 1.9772 times 10 to the power of 8. Alright, so then we just because we want to find the wavelength 2, so we just do like this, right? 1.9772 times 10 to the power 8 over 3 to the power 3 times 10 to the power 8 times 632.8. Alright, so from this we will have 417 nanometer. Alright, so we have complete for the B, the wavelength. Right, so then this question is asked us to find the frequency. Okay, so from frequency we have the basic formula for for wave, we have V equal to F lambda. So because we want to find the F, we want to find the frequency, and we already have the velocity and the wavelength. So we just put all the information that being given, 1.9772 times 10 to the power of 8 meter per second negative 1. So we can get this information from here, alright? Because if we want to find the velocity equal to c over n1, alright? So then I just put the value right here, and then the lambda, the wavelength that I already calculate in here. However, in this answer, the answer in nanometer, right? So I decide to change it to 10 to the power of negative 9, because it's easier for us. We have to because we have to find the we have to solve this question in the meter, right? So from this we can just cut the m, the above m. So from that we just divide, then we can get 4.741 times 10 to the power of 14 hertz. Alright, because it is frequency. Then lastly, this question is asked us to find the speed in solution. So speed in solution we already have in here. Alright, so we can find the speed in solution from here. Alright, because formula for velocity is equal to c over n. So we already have calculate in here, then we just move the answer to here, then we already have. So I hope everyone understand with all of my explanation. If you have a further anything that you don't understand, you can contact me. Alright, so thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Thank you.